is also known as a charged atom. A charged atom is called an ion. An ion is a particle formed from either the gain or loss of electrons. Ions can tend to be positively charged or negatively charged. If an ion is formed from the loss of electrons, then that atom becomes positively charged. Positively charged ions are called cations, and a negatively charged ion is called an anion. So let's give two examples, one to gain and one to loss. We're going to have aluminum as one example and nitrogen as another example. Let's start with aluminum. Aluminum's electronic structure is 2H3. It has 3 valence electrons, or electrons in its outer shell. Because it has 3 electrons in its outer shell, aluminum tends to lose these electrons to form an ion with a 3+ charge. We write this charge as a superscript when writing the symbol. So the symbol for this would be Al, the superscript 3+ ion. You write the word ion, so you advise the reader that it is an ion with a +3 charge. Now when we're drawing the electron configuration, you want to enclose it in square brackets, and then after that, you put the charge as a superscript on the top right-hand corner of the square bracket, not inside, but outside, as shown. Let's put this to work with nitrogen. Nitrogen has an electronic structure of 2 and 5. Therefore, it has 5 valence electrons. Nitrogen tends to gain 3 electrons to form an nitride ion with a -3 charge. So the symbol would be N with the superscript 3-. And then you write the word ion. Again, you write the word ion to advise the reader that you were talking about an ion with a -3 charge. In this case, it's a nitride ion. And then remember to enclose it in square brackets when drawing the electron configuration. Now, why am I calling it a nitride ion? This is because during a non-metal, you need to keep the first syllable there, and then drop the rest of the word and change it to an ion. Nitrogen, it's nit. So that means that nit stays there. Now the ogen part of nitrogen is dropped away and replaced with an ion. Nitrogen becomes nitride. Looking at these 2 ions, we can see that they have a full outer shell, and they have the same electronic structure as their nearest noble gas, in this case, neon. So if we compare the 2 ions, we can see they are the same. Bringing them together, along with the neon atom, you can see that their electronic structure is the same, meaning that the ions formed have 10 electrons. In fact, aluminum nitride is actually an ionic compound. We're going to learn about ionic compounds in the next episode. What do calcium and potassium have in common? They are both metals, and because they have a small amount of valence electrons, then they tend to lose electrons to form cations. Group 1 metals, such as potassium, have 1 valence electron, and they lose this electron to form an ion with a +1 charge. Group 2 elements, such as calcium, have 2 valence electrons, and they lose these electrons to form ions with a +2 charge. Transition metals and lanthanides and actinides all have at least 1 charge, a +2 charge. Now, group 3 elements, such as aluminum, tend to lose 3 electrons to form ions with a +3 charge. Group 8 elements, like radon, don't tend to gain or lose any electrons. They tend to form ions with a charge of 0. Group 7 elements, such as chlorine, tend to gain 1 electron to form ions with a -1 charge. Group 6 elements, such as sulfur, tend to gain 2 electrons to form ions with a -2 charge. Group 5 elements, such as nitrogen, tend to gain 3 electrons to form ions with a negative 3 charge. Group 4 nonmetals, like carbon, tend to form covalent compounds. In conclusion, an ion is a particle formed from either the gain or loss of electrons. The ions formed have the same electronic structure of their noble gas. If a noble gas is going to become an ion, that ion will have a charge of 0, meaning that it will not gain or lose electrons in their lifespan. Helium might be kind of confusing. Because it is a noble gas, but it only has 2 valence electrons, it should lose these electrons, right? But remember, helium has a full outer shell, meaning that helium will actually not gain or lose any electrons. Namely, noble gases have full outer shells of electrons. Therefore, they do not tend to gain or lose any electrons. Well, that's it for Making Math Easy, and remember you to stay curious in math and science.